Good day, everyone. Today, we'll be analyzing two movements. The movements were performed by a university student and a 7-year-old child to observe the differences between the two. To ensure consistency in variables, the same ball and instructions were provided to both participants. The feeder was standing 2 meters away from the participants. In the video, cameras were set up at two angles, from the front and side at a distance of about 2.5 meters away. The first movement, which is the overarm strike, occurs when the arm or hand, with or without equipment, applies a force that sends an overhead object away. Here's the real-time video of the overarm strike, executed by both participants. The instructions were given as such. A demonstration was also done once to the child. Now let us watch the video in slow motion to break down the movement, beginning from the head down towards the lower limbs. Here we can see that the eyes of both participants are focused on the ball. Although not visible in the video, the student was actively aware of the goalposts. The shoulder of the non-striking arm is higher than the striking arm, as seen in the student, whilst in the child, both shoulders are leveled. Next, the elbow in the student is angled at less than 90 degrees, while the non-striking arm is used to gauge the depth of the object. However, in the child, we can see that his elbow is straightened and locked while the non-striking arm is by the side. Trunk rotation is close to 90 degrees, while that of the child is less than 45 degrees. Similarly, this can be also observed for the pelvis. Moving down to the lower limbs, the student, we can see that the feet are placed apart, angled to the side, 1 foot in front of the other. This gave the student more stability and increased his range of movement. In the child, his feet are placed side by side, squared to the front. Next, we will examine the movement patterns in the execution phase. Upon contact with the ball, we noticed in the student, the shoulder of the striking arm is higher than the shoulder of the non-striking arm. In the child, we can see that his shoulders are leveled. This limited his range of motion, therefore hindering his ability to drive the ball away forcefully. The student's elbow is fully straightened, and there is a differentiated action of the upper arm and forearm. In the child, however, we observe that his elbow collapsed and bent at 90 degrees. Therefore, this reduces the amount of force produced. The trunk and pelvis of the adult is rotated about 90 degrees in the direction of the strike, generating more force, whereas in the child, his trunk and pelvis remain stiff. The body moves forward with the waist as its focal point. The knees of the adult are slightly bent, while there is minimal bend in the child's knee. Moving down to the feet, the adult's feet are approximately shoulder width apart, while the distance between the child's feet is greater than shoulder width apart, compromising his stable state. Lastly, the follow-through phase. We can see that the shoulders in both student and child begin to level after contact with the ball. This allows both participants to regain their stable state. Next, we can observe the differences in the ending position of the arms. In the student, we can see that his elbows and arms follow through completely, where the ending movement is near the opposite hip. This motion counteracts the force produced by the body, allowing the student to return to a stable state. While in the child, we can see that there is a slight follow-through. However, the ending movement does not go beyond the body. In order to generate maximal force to drive the ball away, the trunk and hips must rotate. As seen in the video, the student's trunk moves forward beyond that of the opposite shoulder. In the child, the trunk moves slightly forward but does not rotate towards the opposite shoulder. The hip of the adult moves beyond the opposite foot, while the child's hip only moves a short distance beyond the opposite foot. Moving down to the lower limbs, we can see that the legs and feet transfer the weight fully. The rotation is more than 45 degrees as the weight is shifted to the front foot in the adult. The transfer of weight was a result of the trunk and hip rotation. This allowed the student to regain stability from the force produced. In the child, the legs and feet did not transfer the weight fully, and there was minimal rotation observed. Why was the student able to execute the movements better than the 7-year-old child? Here we will touch on some growth and motor development theories to explain the reasons why. Using the principle of development direction, we can see in the video of the 7-year-old child, the structures in the upper body, like his eyes and upper limbs, seem to be more developed than his lower limbs. He was able to successfully track the ball and use his hands to retaliate. However, due to the lack of development in the lower limbs, he was unable to generate force to drive the ball away. With the use of the visual system and the IPP theory, the visual information is processed by the brain to provide information about our environment, after which outputs the movement. However, without prior experiences, he was unable to perceive depth and distance of the ball. As such, his elbow had collapsed to strike the ball. Even though stability is compromised when executing the overarm strike, the response selected during the response selection stage is deemed to be the most ideal one. The second movement is the volley. Volleying refers to a shot or kick made by hitting the ball before it touches the ground. The instructions were given as such, and a demonstration was also done once to the child. Here is the real-time video of the volley executed by both participants. Firstly, we will examine the different movements involved with the preparatory phase, beginning with the head to the lower limbs. The student has his eyes focused on the ball as soon as it is fed to him, all the way to the point at which he makes contact, while the child is not able to track the movement of the ball as accurately. Next, notice the difference in the position of the arms. The student has his arms placed outward in a position that will allow him to swing and counter the momentum of his kick to maintain balance, while the child has his arms by his sides. In order for maximal power to be generated to drive the ball forward, the trunk and hips must rotate. The student has his body in a position that will allow this rotation to occur, while the child has his body squared towards the ball and goal. Lastly, the legs. The student has his knees slightly bent, his non-striking leg in front and his striking leg cocked back into a position ready to strike. The child's legs and feet are squared towards the front with no adjustments prior to the kick. The next phase will be the execution phase. Both subjects' eyes are now focused on the ball. We can start to see even more differences between the student and the child in this position. The student's arms are out to the side, swinging to generate more power and counter the strike from the legs. The child's arms are mostly still to his side, and while it can be observed that he swings his arm upwards, the movement does not contribute to power generation. The trunk and hips of the student is rotating inwards to generate power for the kick, while the trunk and hips of the child still faces towards the ball and goal. As for the legs, the student's thigh has rotated forward and is extending his knee to strike the ball. Although difficult to see, it should also be noted that the student's toes are pointed downward. Due to the child's trunk placement, there is no rotation of the hips, and as a result, the non-striking leg remains facing forward, while his striking leg begins its motion from a standing position instead of a proper preparatory position. Lastly, in the follow-through phase. Here both subjects' eyes are focused on the ball and where it lands. The child displays elementary and mature development the same as the student. For the developed student, the arms move in an opposite direction to counter the momentum generated from the kick in order to maintain balance. As for the child, the arms are slightly elevated, however he does not use them to counteract any force, nor does he use them to maintain his balance. The trunk of the developed student has rotated to the side, while the undeveloped child has his hips squared. The developed student's legs swing past as he follows through with the motion and is able to maintain balance on a non-striking leg. The child, however, quickly snaps his striking leg back to the ground to regain his balance. What we observed is in line with what is to be expected in early development kicking compared with proficient kicking. In early development kicking, it is a single action rather than a sequence of body actions. There is no stepping with a non-kicking leg, the striking leg is not cocked, arms are stationary, and there is minimal trunk action. In a proficient kick, as we have seen, there is a preparatory windup where the trunk rotates backwards and the kicking leg is cocked. The whole action is a set of sequential movements. The kicking leg sweeps across the body and the arms are used to maintain balance. The child displays early development of postural control. However, as soon as he makes contact with the ball, he begins to lose balance, which results in a lack of proper follow-through. In a proper follow-through, the striking leg will swing across the body and the arms will move in opposite direction to counter this momentum. However, the child's striking leg quickly snaps back below him to gain footing and regain balance. Development in his visual system can be said to be in early development phase as well, due to his inability to properly gauge the ball as it is fed to him.